Please start.
Well, she had a message for you, but apparently she forgot, people. There's not for you. I, on the other hand, do have a message, and it is like Ashley's lucky day because I feel that if I have to give the footballers an extra day, then I can also give you an extra day, Ashley. So don't press your luck. And what I'm talking about footballers is today, as I told Johnny Sidel Prado, and he probably forgot, is I need your binder. Now, obviously, you're not here. So unless you can teleport your binder to me, you're going to have to give it to me tomorrow. Just remember, we don't have class tomorrow. I am not going to chase you down. You need to remember to bring me your binder tomorrow before the end of the school day, which is 12:35. Yes. So if it's not here by 12:35, not 12:36, 12:35, then I will not be giving you credit for your binder for this quarter. Ooh! So, those of you that already have it here, thank you.
You're welcome.
And keep it here when you leave today. And if you do not have it, then you have one extra day to do that. All right, now, enough of that. So, equations of circles. This is the standard equation for a circle. And I know that I'm hoping that by now you can trust me when I tell you things about difficulty. I don't try to lie to you. Some topics are really hard, some are really easy. And it is my opinion that this topic is actually a fairly easy topic. I will be honest with you, I do not like to graph a lot of things. But circles and trig functions are quite easy to graph. And circles even more so than trig functions. And trust me, we'll get to trig functions later in the year. But, yay. This is the first one we're going to do is circles. You guys know what a circle looks like? It's round.
Yes.
Yes. The definition of a circle is basically that all points that are equidistant from a center. So that's why all the radiuses or radii are always the same in a circle and blah, blah, blah. But this is your equation of a circle, standard form. And in this equation, you'll notice a couple of variables. The h and the k are always your center. You should also notice that the h in here is negative and the k is negative, but it's not negative in the center, like when you write the center. So it's always the opposite. If you have a -3, you're going to have a +3 for your center. If you have a +4, you're going to have a -4 for your center. It's always the opposite. And then the other thing is the radius. A lot of times I will get like an equation that equals 25, and someone will tell me the radius is 25. The radius is not 25, it's just r, it's not r squared. So if this equals 25, that would be 5 squared, right? So the radius would be 5, not 25. So be careful with that. But that's your formula, if you will. So we're going to get started with some examples. Here's example 8. And they want us to graph this circle, and it's really simple to do. And I will show you how. The first thing you want to do is extract the center and the radius from your equation. Now, because you don't have the parentheses squared, you could, if you wanted to, do this. It's not necessary, but I'm going to do it right now so you can kind of see the standard form taking place. If I wrote it with the h and the k in there, you would basically have a 0 in those spots. So that would mean that my center would be 0, 0, and my radius would be 5. So graphing this is a very simple technique. You just plot your center, which in this case is going to be 0, 0, right there on the origin. And then because all of the radiuses are the same, and it's 5, you want to go 5 units in all directions. So it's just easy to go 1, 2, 3, 4, 5. You can go in diagonal directions if you want, but that just makes it more hard. It makes it harder. Let's speak proper English here. It makes it more harder. It makes it harder. There you go. So 1, 2, 3, 4, 5. There you go. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I just went north, south, east, west, basically, in 5 units each direction. So I'm going to put points over here. Now remember, the center, although very important, is not technically part of your graph. It's not actually on the circle. It's just telling you that all of these points that are on this circle are going to be 5 units away from 0, 0. So you just try to get your best circle going on.
Oh man, that was so good.
It's not that great, but it works, and that's all you have to do. Bam, it's graphed. There are not many graphs that you can graph that easily. Find the center, know what the radius is, plot your center, and then go from the center, however many units your radius is in all 4 directions, and then draw your circle. Yes?
Wait, how did you get the x minus 0?
I wanted to put it in the right standard form. So because there's no, it's just x squared. So the x minus 0 would be x, right? So x squared. This is just a technicality. Basically, when you have x squared and y squared, it's just 0, 0. And this is y. But you don't have to do it that way. I'm just showing you that now if I do it like that, I can see clearly that it has the same form as this. Okay? And so now for part B, same thing, only in part B, you actually can see that there is an H and a K, right? And so the first thing I want to do is identify the center. Remember what I said about the value being opposite? Because this is a -2, we're going to have a +2 for my x and a -1 for my y, for my center. And the radius is going to be 5 again, right? This is 5 squared, so 5. So when we graph this little sucker, it's almost going to be the exact same circle in the sense that it has the same radius as part A. It just has a different center. Instead of being at the origin, we're going to go 2, -1. So here is 2, -1. So now my center is going to be here. And now from the center, I need to go 5 units east, west, north, south. So if I go 5 units this direction, I'm going to be at 7, correct? This is already 2, 3, 4, 5, 6, 7. So there's going to be a point there. And then over here, I'm going to go, from here, I'm going to go up. I'm already at -1 here. So I'm going to go all the way up to 4. Okay, so that way if I'm starting from here and I go north 5 units, 1, 2, 3, 4, 5. If I go west or left, I'm going to have 1, 2, and then 3, 4, 5. That's going to be -3. So 1, 2, 3, 4, 5. There's my point. And then this was a 7, right? And then the last one will be, I'm already at -1. If I go 5 more, where will I be? -6. So it's -1, -2, -3, -4, -5, and -6. Put my little point there. And so now my center has changed. It's not at the middle. It's not the origin anymore. But, nice. That was better than the last one. And then you just draw your circle. It would help if you had a compass, but I'm not requiring you to have one, so there you go. Because the center is 2, -1. So you're going to go x is 2, y is -1. Put a point. 5. So you have to start from your center and go 5 units to the right, to the left, up and down. And then just try to connect them with a nice circle. Trust me, I get some funky shapes. Sometimes they're rectangles. But yeah, squares. So are we okay with this? Yes, people?
Yeah.
Yes.
Okay. So now we're going to abandon the graphing portion of it
Why is mine looking like a square?
because you're not as trained to draw circles.
Did you just go, yeah,
So, yeah, we don't want ellipses, we want circles, but just do your best. Lucky for you, you have WebAssign that will help you, make it look like an actual circle. So, here we go. Example 9, unlike what we just did, is asking you to write the equation of the circle. So they're giving me the center, they're giving me the radius, and they want me to write the equation. Again, very easy to do because we know that it's supposed to be x minus, so it's always the opposite, remember? So if this is a +2, what should be in the parentheses? A -2. And since this is a -5, This is going to be,
Positive.
so it's actually y minus -5, which is y plus 5, so there you go. And since my radius is 3, 3 squared is, and that is how difficult that is. That is your equation right there. You don't have to like simplify it any further. You don't have to multiply it all out. You just leave it like that. Yes?
Wait, no.
Yeah.
No.
I was still trying to figure out my square.
Time. So the next one we're going to do is not going to be as straightforward, but you realize that the only way that you can write the equation of a circle is if you know the center and if you know the radius. That's all you need. So in the next example, we're going to have where they're not telling us what the center is. But we're going to use our midpoint formula and our distance formula to figure it out. So here's part B. What they have given us are the end points of the diameter. So what you should know about a circle is that the diameter has to go through the middle. Otherwise, it's not the diameter. Otherwise, it would be a chord if you just went like here. So when they tell you that it's the end point of the diameter, they're basically giving you this point here and that point there. So to find the center, we would need the midpoint formula to find the center. And then to find the radius, we would have to use the distance formula to go from one of the endpoints to the middle. That would be the radius, right? That's what we're going to do. So let's start with the midpoint. That's going to give us our center. So I'm going to go ahead and use C for center. But the midpoint formula tells us to take the x coordinates, add them together. So I'm going to add 1 plus 5 and divide by 2. Right? That's midpoint formula. Then we're going to take 8 and -6, divide by 2, and that's going to be my center. So I'm going to get 1 plus 5 is 6, 6 divided by 2 is 3, and 8 plus -6 is 2, and 2 divided by 2 is 1. So there's my center, 3, 1. Now I'm going to use the distance formula so that I can get the radius. So I know that this point right here now is 3, 1, right? And one of these points is 1, 8. It doesn't really matter which one. So there's 2 ways you could do this. You could find the distance between P and Q and divide it by 2 because the radius is only half of that, right? Or you could find the distance between here and call it a day. And that's what I'm going to do. I'm going to use the midpoint and the end point to get my radius. So distance equals?
X2
Right, so we're going to go 1 minus 3 squared, and then 8 minus 1 squared. So 1 minus 3 is -2, and -2 squared is +4. 8 minus 1 is 7, 7 squared is 49. So 49 plus 4 is 53. So the radius is the square root of 53. Yep. And that can't be reduced. Right? No perfect square goes into that. So my answer for my equation is to put it all together. I'm going to go x minus, the center was 3, right? And that makes sense because it's a -3 here, it's a +3 there. Then we're going to get y minus 1, and then it's r squared, the radius squared. The radius is square root of 53. If I square this, what do I get?
53.
Just 53. And there you go.
What?
You have completed part B. And then we have one more to do. Are we okay with that?
Yeah, I get it.
Okay, so now we're going to do example 10. In example 10, they've given us an equation, if you will, but it's not in the right form. We're used to seeing the squared, the x minus something squared, and it's not like that right now. So basically what you have to do here is complete the square twice. Woohoo! We're going to complete the square twice. So what you want to do is combine your like variables, if you will. you want the x's to be together, so I'm gonna do x squared, and see how it has y squared here? I'm gonna skip that and go to the 2x. I'm gonna leave a blank, because when you complete the square that you do right, you leave a blank.
Yeah.
Then I'm gonna put the y squared and the minus 6y, leave a blank, and I'm gonna take the 7 to the other side.
Okay.
Job? Then we're gonna complete the square for the x's. Do you guys remember how to do that?
Oh, it was,
Get P divided by 2.
So the middle term
divided by.
divided by 2, and then you square that, right?
Yeah, so it's 1.
So you're gonna add 1 here, but also add 1 over here, right?
Wait, how do you actually something that's there?
Always take the middle term and divide it by 2,
And then square it.
square that result, and then that's what goes in the blank.
Okay, this one too.
So for the y's, we're gonna take negative 6 and divide it by 2,
Which is 3.
which is negative 3. Square that, you get 9. So I'm gonna add 9, add 9. Right? Let's do eggplant, yes, eggplant. Hold on, peeps, don't go anywhere just yet, we're almost done. So the final step is to write it as a factored form, right? So that will always be the number before you squared it. This will always be what goes in here. So all of this, x squared plus 2x plus 1 is the same thing as x plus 1 squared. And then we're going to take y minus 3, because again, it's always the number before you squared it that goes inside the parentheses here. And on the right, we have 9 plus 1, which is 10, and 10 minus 7, which is
3.
so there's your equation. And earlier you were asking me about the formula, right? For when something's squared. And I told you it was a squared plus 2ab plus b squared, right? So in case you're not believing me, if I were to take this and factor it out, Nyla, it would be a squared plus 2 times a times b, so 2x plus b squared. Isn't that what that is?
Yes.
See? If I do it here, I would go y squared minus 2 times a times b, so minus 2 times 3 times y, plus 9. And that's what that is, right?
And that's.
So,
What were the directions for this? To.
so the key is, I'll say it one more time before I cut off the video. The key is to always divide by the middle term by 2. And then when you square that number, this is the magic number right here. The number before you square it is what's going to go inside the parentheses. The number before you square it is what's going to go inside the parentheses.
Okay.
So then this becomes your equation. That's what they
But
wanted.
that's the factor.
We're done.
The-
No, they wanted the equation of the circle. But this is not in the right form. Now this is the right form. So can we push on record or stop record or? Thank you.